Andrzej Krzemiński.
Hi everyone. When preparing for this talk, I came across a study on what people fear most. It said that people's fear number one was performing in public. Like here. Do you know what was number two? Death. So for a couple of years, I worked on a live critical system, and this is where my sort of hobby came from. I just keep record of every interesting bug I got hit with, or my colleagues. Because not all of them are interesting if you have if statements with conditionals that span across a few screens, or if you're using keyword delete. It's obvious that you have a bug, you asked for it, there's nothing else that can be told about it. Just fix it. But there are other bugs that make it into our code even when we take all the necessary precautions to avoid them. This is what makes them interesting. This is what I try to collect, identify the patterns, and see if they can be mechanically eradicated. And this is what I will be sharing with you today. This is going to be two talks, one right now, the other at noon sharp. In this one, we'll go through one example, and we'll do it the way we usually come across the bug. So first, we'll try to find it in the code examples. Next, we'll try to identify the root cause, because even if we can see that the bug is there, it's not obvious in which place to fix it. And if you try to fix it in the wrong place, you only change one problem for another. Once we do that, we'll see if there's any advice we can draw from it. Usually when we think about bugs, we connect it with application crashing, but it's not the worst case that can hit us. What you see in this picture is a result of converting a 64-bit floating point number to a 16-bit integer. This is the Ariane 5 rocket, which crashed just before it took off and cost European Space Agency $500 million. So there is known ways to detect consequences of a bug at runtime, but usually there is no good, even though people do that, there is no good action to be taken at runtime. This bug was detected by hardware, the conversion overflow, and the processor did signal a hardware exception. But what do you do with such an exception? The rocket needs to be controlled, and the fact that you have a bug doesn't help it. So we'll not be focusing on detecting bugs at runtime. It's just too late. Also, fixing bugs, this is what we do and probably must do, but usually, or sometimes, it may be too late to fix a bug found in production. If the software is working on an equipment that exposes people to radiation, for example, in cancer treatment, if you overdose the radiation and happen to kill a patient, there's no way to fix that, right? So also, we'll not be focusing on that. The only interesting thing in focus is not having bugs in the first place, and this is what we'll try to aim at. And while it's not possible in general, we'll at least try to get close. Our example deals with authentication. So somewhere in the program, we have a module for authenticating users that is checking if we store a record of them. And we have a code, although the code snippets are in C++. This is my language of choice. Somewhere there, we have a function, not here, here, that gets a username from somewhere. It forms an SQL query that will check if this user exists or is recorded in our table. And once we have this query, we'll pass it to some SQL interpreter. I just invented this syntax, this library here so that the example is short. Normal code is probably different and longer, but you get the idea. We pass the query, we get the result back, we expect an integer saying how many records of this guy we are storing. We cast it to an integer, and we give the result back. We don't see many things here. We don't know how this library is implemented inside. We don't know if when the program is run, if it will have a connection to the database, if this table really exists, whether we have access to it, whether it has the right columns. There are many unknown things. We should take care, consider them at least, but we'll move it out of the picture for the sake of the example. There are also other questions to be answered here. What does it mean if this guy returns a negative number? What does it mean that we have a negative number of passengers? This is a valid question. We should address it at some time. But again, this is not the biggest problem in this code. It contains a serious bug. And I wonder if you can see it. Some people can already see it, thank you. If you don't, if someone doesn't, that's okay, it's easy to miss it. And this is the talk for you. We'll try to see how we can spot it immediately. Normally, when we look for a bug, we look for undefined behavior, but yeah, there is none here. There is no pointer accessing a null pointer or over-addressing the array, none such things. So if we like to find the bug that we expect is there, and we should expect it always, we should consider how this function will be used. You cannot see a bug from here until you look at the bigger picture. Probably in the higher level of the applications, someone will be reading the from user interface, this username, either from a command prompt or from a text window, and passing it down to us. Yes, you can either see the problem now or not. If you don't, the approach is to try to look further how this application will be used and how it can be misused. What can be the most malicious input we can get? And this is what some of you have said already, what a hacker can type into our system. It doesn't look like a username, it's a partially formed SQL statement, but when it gets down to where we build the full query, we are actually now having two queries instead of one, the second of which wipes out the data from our table. True, this is called SQL injection, but for the purpose of this talk, it's enough to call it a bug. It may be not easy to think about it this way. Is a hacker attacking our system a bug? Not exactly. The hacker is the user, whether we want it or not, and he is free to type any input he wants. That's okay. It's not within our control, so we cannot be held accountable for what he chooses to type. But allowing his input to go too deep into the guts of our application, unprocessed, where it can do arbitrary harm, is a bug. It is definitely our fault. And when you look from the outside of the application, when it's supposed to authenticate users, and what it does instead is wiping out the data from the database, you cannot deny it's a bug. And you cannot even say, you don't want an SQL injection, just write a user story for it to implement it. It doesn't work this way. It's your implied responsibility, even if you don't know about it or forgot about it. And you have to do it, even if nobody requests it of you, or if nobody gives you a credit for it. One thing to note is that this is not a live critical system, even. It's just a normal application that happens to need to authenticate users. Yet the consequences of a bug can be so severe that you cannot afford the approach that I have seen far too often taken. Let's just deliver what we have and fix it in the next release. There may be no next release if you get into legal problems with losing customer-sensitive information. And you may say that it's easy for me to talk like that there is a bug, you should have found it, but I wouldn't have found it in production, really, when I was looking for the code. Because some of those just slip your attention, whether you want it or not. True, I probably wouldn't have spotted this bug myself, because if I wrote this code, I have sit 8 hours on a computer typing it. I'm tired of it, don't want to look at it anymore. I want to go home. Now, if I were to prove that I am wrong, what am I getting? I'm proving that I suck, and also this means that I'm staying longer to fix it. So my motivation may not be that good. I may be even in a conflict of interest here. But if I ask you, well, you found it already in the first place. Your approach is different. You didn't write this code. You don't have personal feelings towards it. You're fresh. Yeah? You will not be fixing it. And more, you have this pleasure of proving me that I am wrong, yeah? And you are better. So you are far more likely to find it. And if I wanted to help you, and I probably should, I should write the code in a way that makes it easy for you to find a bug. So I probably should make it clean, self-explanatory to the extent that I can. Use some comments to indicate what my intentions are, what my assumptions are, give you any possible hints that will increase the chance of you finding the bug. So that's it for the first part. Now, to the root cause. There are at least 2 places, we've seen 2 functions, where this input could have been prevented. At any point, we could have filtered out this input, but it does matter where we fix it. If we consider this authenticate first. There probably should have been some authentication here. You don't use unprocessed user input, you should validate it. True, but validate it against what? How do you know what spoils the other functions down there? We know because we've seen the other function, but normally the caller doesn't know what's inside the callee. So he doesn't know. True, we are using the database here, but there are other ways of accessing a relational database without SQL, like object relational mapping, for instance. Or we may be caching the database into our in-memory table. And there is no problem there. No input is going to spoil our program. Also, this may happen, whatever rubbish the guy types in the command may happen to be a valid name. So it's only after we have executed our function, does user exist, that we know if the name is valid or not. Whole authentication is the process of validating the input. So there is nothing particular that we can pre-validate there that we know of. On the other hand, when we look at this function, does user exist, if we look closer to answer the question, how did it happen that the bug got there in the first place? This is because we assume that we are really dealing with usernames, whereas we are not. We are building an abstraction here, even there is no virtual functions or object-oriented things, we are still building an abstraction, which lets other people think that we are dealing with usernames. But in fact, we are just getting a string, an arbitrary sequence of characters, we are concatenating it into bigger sequences of characters, and that's it. There's no more about it. We are just passing it to the interpreter, which takes one sequence of characters, turns it into another sequence of characters. This is a different way of looking at it. There's no username anymore. It is just strings. So we are building an abstraction, and we should, because normal people cannot comprehend this, the entirety of the program when it's just bits. We have to make abstractions to let us survive and let the colors think in terms of abstractions. But we inside, when we implement the abstraction, need to go down and think in terms of bits. This is why hackers can so easily beat the entire team of good programmers, because they don't need abstractions. They only see bits, memory addresses, stack frames. So you need abstractions, if not for anything else, it's to communicate with your colleagues. But when you get hung on to the abstraction too much, you fail to notice, so I try to depict it here. If you're thinking in terms of abstractions, the only thing you see is the abstraction. But the real world that the hacker sees is that only some of them is the abstraction, the username, and there is this abstraction gap, which you are probably not prepared for, and what he can exploit. If there are more layers of the application, there are more of these gaps, and every one of these gaps is a chance for a hacker to do something you don't want. So you may think you are passing usernames, the guy sees just sequences of characters. You think you are querying for your username, he just sees concatenation. You see all these abstractions, the hacker sees all the gaps. In the end, you think you've built a perfect tool for authenticating users, but the hacker has a perfect tool for executing arbitrary SQL commands. So what we are dealing with here is one other thing to have in mind, because this is a very negative view that I am giving, that this abstraction worked for a long time. It really validates users in the other case, so it makes sense, but only within some limit. It's only for a subset of the possible input values that we get that our abstraction will work. And this is called a precondition in this industry. This language, C++, doesn't have preconditions or any tools for helping you there, but the preconditions are still there. It's not part of the language. It's part of our thinking of abstractions. And we had one precondition in our code, and I failed to notice it here. So when you have identified a gap in your system, like a precondition here, you can try to name it formally by defining a predicate, a function that will take the same input and will tell you whether it's acceptable for our abstraction or not. Once you have it, it's easy to define what I call it identifier. It's something that's letters and digits and nothing else. Once you have it, you want to communicate it to the callers that will be using our function. But you may ask, why do I have to communicate it rather than evaluate it myself inside the function and not bother anyone else outside? This is because, while you can check it in runtime here, when you get it, it's not clear what you are supposed to do with it, with this information, that you got an invalid input. Just consider the Ariane 5 rocket. It also detected a bug, but at this point, it's too late to take any meaningful action. You can think of throwing an exception, like escape hatch, where you don't know what to do, I throw exception. But who is supposed to handle it? The problem, the precondition breach, is caused by the caller. So he could catch the exception, he could add a code for catching exceptions inside him and try to respond to it by, for example, giving another user input. But if he is forced to change his code anyway, why let him catch an exception and not check the precondition up front? If you move the precondition check into the caller, because he has access to user interface, there is no notion of an error or something unexpected anymore. For him, it's an expected situation. The user types whatever he wants, whatever rubbish, and the program here can politely say, just give me another input, and another one, and another, until you gave me the right one. No error, it's just a normal program flow, and you know what to do at every stage. So I hope I convinced you that this is the caller that's supposed to check these preconditions. So now we are shipping two functions. Our primary function that does the job, this does user exist, and a precondition or a set of preconditions that define when our abstraction works. And back to the question, how do we communicate it to the caller so that they know what not to give us? Well, the bad news is there is no good way to do it. But the good news is that it doesn't matter, because the important point is that we are able to identify these preconditions, we are able to name them, and we are willing to communicate them. And this is enough to survive here. If there's no other way to communicate it, you can just go to your colleague and tell him that if you're writing this program together, that you have one, or you email it, or document it in documentation. That should be enough. At least it increases your chances of filtering this bug. But we'll be now talking about how we can do it in the language. Comments, the most useful language feature in nearly every language. If it doesn't allow you to do it otherwise, you can always use comments. You don't like the comments because there are just letters without meaning. You can give it some structure so that you are using the predicate you've defined, you are using the same username. They become more formal. It's now like mathematical notation, which really conveys some meaning. If you want something more, you're not satisfied with comments, there is one library worth knowing of, is this contract++, recently adapted into Boost, but not shipping with Boost yet, which allows you to declare a function along with its precondition. What you get is that the compiler will syntax check that your precondition makes sense. And it will give you an error if you, for instance, refactored the function signature but forgot about the precondition. If you need it, it will also insert a runtime check in the function where you define it, which will terminate the program when it detects a violation. Termination looks a bit harsh there, but it's supposed to be the double check. The primary goal of this thing is to put a declaration to the callers that they can see what they should avoid themselves. In a double check, it isn't that harsh anymore to terminate the program upon detection of such a problem. Even Ariane 5 wouldn't mind that we crash the application when it's crashing anyway. But while it's worth knowing of, I'm not comfortable really recommending it for production use because it uses hell of a lot of macro and template metaprogramming. I had to put those parentheses there. If I didn't, I get a ton of errors I don't know what to do with. There is a simpler tool, always at our disposal for years. It's just assertions. I notice some people don't like assertions for different reasons, because this is a macro, this disappears in production, or it terminates the program. They're all valid concerns, but they're not that important. The primary goal of an assert is to be there. It's a comment, except that the compiler will syntax check it, whether it's correct and whether it makes sense. This is an information. One drawback of it is that it's not in the declaration, so our callers don't see it from the outside. But it's still useful for someone, for instance, that reviews our code. This is a hint you can give to your reviewers, what your assumptions were. It can help verify whether your implementation goes with the assumption. And you can combine it with comments. So again, you're increasing the chances of finding the bug before it goes out. So this doesn't look good. The ideal solution was if we had a static analyzer that can just check every possible precondition mismatch and tell it to us before the program is compiled. We don't have it, at least yet, but we can try to emulate it. We always have a type system at our disposal, and we can turn a precondition violation into a type mismatch. And sometimes it happens to work. If I, instead of a string, use another type identifier, and someone reads a username from a command prompt and passes it to me there, now I get a compile time error. And he sees immediately, he will not even be able to compile the program because the compiler will tell him, you have a mismatch here. It's a type mismatch, but you know it is about, now you know it is about the precondition breach. How you can define such a identifier? It's pretty simple. It's just a string inside. It's still the size of a string, and the only interface it has is two conversions. You convert a string into this identifier with an explicit constructor, and you get the conversion the other way. So in this example, I didn't care about performance, so every string is passed by value. When you do it seriously, you don't have to fit it into the slides. You will use a move constructor with value reference to make it faster. You get a type with the size and layout of a string, two conversions. It's not like an object-oriented style class with some do-work methods. Its only purpose is to alter the type system. And once you have it, you can indicate your precondition. If you are perceptive enough, you will notice that I didn't solve the problem. I only moved it here, because this constructor is another place when you can cheat the system and pass it to any string where identifier belongs. True, it's not an ideal solution, but it adds one important benefit. Now I still can do the same mistake. I re-implemented my bug here, but I cannot do it by mistake. I'm forced now to request the conversion, and while I am doing this additional typing, at least I have a second to think, why am I forced to do this? What's the purpose of it? And this might be just the second that saves your life. Also, when it is implemented like that and it is a bug, now it's clear at which point it is. Now we are sure it's not this does the user exist that has a problem, but our authenticate function, because it makes this signature that I'm doing the conversion and I'm taking responsibility for whatever gets out of it. So if you have 1,000 functions or 10,000 functions in your program, you probably don't want to add 10,000 of these additional classes. But if you identify that some preconditions occur and reoccur again in different parts of the code, you can define this type once and reuse it in many places. The effort will pay off. For instance, here I was able to convince the user interface to also speak in terms of identifiers. And this way, I have no casts involved anymore. It's all as short as it was initially, except now that it is safe, at least with respect to this string being an identifier or something else. Plus, if you use this technique of constrained types, you get other benefits. For instance, consider that I have to write a function that tests if there is a file in the file system existing and being owned by a specific owner. And I return a true or false answer. If I declare it like this with the strings, I risk certain bugs that can sneak into my code. I can, for instance, confuse the order of arguments. And now I'll be testing something else. The compiler will not warn me, and the program will be running, except that it will be doing something else than I wanted it to. And because it takes two strings and returns a bool, it's a perfect candidate for a predicate. You can sort with it, but you don't want to be there when this sort is executed. And that's it. That's the best idea I can come up with for declaring the preconditions and reusing the compiler. If you can do it, it really helps. Otherwise, the other thing you can rely on is reviews. And when you ask your colleague for a review, make sure the code is reviewable. So now I will have a question for you. We've talked about this function, this identifier. Now it's time to implement it. I provide here a very nice, short, and elegant implementation. A string is an identifier. All is a C++11 algorithm that will return true if every element in the sequence is a letter or a digit. Except that this function is wrong. And can you see the bug in it? Who said that? Okay, you get a reward for the answer. Yes, if the string is empty, it's probably not a valid identifier, yet our function will accept it. So it looked nice, the implementation, and now we will have to change it. And I'm not sure if number 2 is a valid identifier. It may be in some context, in some other not. Underscore, the favorite letter of programmers. Is alnum accept underscores or not? Probably a bug. What if it's an international application and it needs letters in other languages? But wait, how do you tell if it's a national letter when you don't know the locale? You should probably know the locale now, because in different locale it may be a letter or not. Does the database use the same locale as you? Another problem. What if it's Unicode encoded, and it's not one character that represents a letter? Now this all doesn't work. So my only point with this example is to show you that even a short function can contain a bunch of bugs. And while elegance is an important part of the code, it should yield to correctness. And that's it for the first talk. Thank you for listening.
Thank you very much, Andrzej. If we can keep you here for a while. First of all, the gentleman who answered the question correctly, what's your name again? Antoni. Please do report to us during the break to collect your reward. Congratulations, by the way. And as we promised, we've got several minutes for any questions that you might have. So now it would be a good time to ask. There are 2 microphones available, so please make sure that when you ask your question, you speak to the mic so that everybody can hear them. Okay, question over there, please. The gentleman there. It's 5 rows down. Very nice, okay. And I'm sorry, the gentleman over there is next, okay? Please raise your hand again so that we know. Okay, that gentleman there is next. Okay, here we go. Yeah, go on.
I guess it's me. It's here.
Okay.
Okay. In your example, there was some extra class to use the system type to help you to detect bugs, like swapped to things like path and file name or whatever. Do you know maybe if we can expect something like this kind of opaque type def in C++? Because normal type def wouldn't work in this situation, and this is a pretty serious thing for some programmer to type this kind of small classes for every case where we need some new type. The use of type def would be much more convenient, just it doesn't work this way. I know if you are aware of opaque type def coming to C++.
So if I understood you correctly, you're asking about something like an opaque type def.
Yeah, that was the question.
Yeah, so there are efforts to standardize it, but that's it. For now, it's just efforts. There are technical. The real problem is it's usually helpful for physical units, where you have a mass, speed. They are all doubles, but you want them to be different types. But it's not clear. You can add doubles, but it's not sure how the opaque type def should behave when you want to add 2 opaque type defs. Whether the addition operator should be inherited also or not. Should it work for mixed opaque type defs? Those are the questions that people try to answer, and this is why this proposal is blocked. Because in practice, when you try to use it, not only do you define the opaque type def, but also like 20 of additional operators. Plus should work again. minus, equals, all the operators, you have to say explicitly what you want to do with them. And it doesn't look that elegant anymore, unless you just wanted two conversions. I think you can write a wrapper yourself, a template for it. Now with inheriting constructors, it should be pretty easy.
Gentleman over there, please.
One question, why do we leave the responsibility of validating whether a string is an identifier with the user of the class? Why not enforce that every identifier has to be correct, right? For example, let the constructor throw an exception when it's supplied with something wrong, or make a static factory method that returns some kind of error code. I don't know, something. So just we can't create some kind of abomination.
So for instance, you want the constructor there of this constraint type to evaluate the precondition and again,
exactly.
Do what? Throw an exception, but are you sure you can handle this exception properly in your program?
Well,
Well, you will answer this question yourself, whether you can or not.
Yeah,
if you
the validation may be available also as a static method on the class, but anyways, when I get an identifier object, I should be able to be sure that this is an actual identifier, not just some string cast to identifier, right?
So for instance, you can make a factory that returns an optional identifier. It's either identifier or nothing. That's an option. If you can provide, you can afford the time for evaluating the precondition. In this case, when you are talking with user, you have enough time to evaluate the precondition. It doesn't affect the program performance. So you can do it. But then you have an optional, and you risk using an, the boost optional library. Like we have a return a value or not. But then we risk that when you have a optional value and you don't check whether it doesn't contain a value, you are just in risk of another bug. But you can do it. Yeah, it's another option.
Just following up the question.
That would be our last question, I think. One more question and a quick answer, please.
Maybe the solution for that is to use some such mechanism as Andrzej Alexandrescu invented. It's probably called likely or something like that. So give the choice for the user. Either check the error or you will have an exception if you won't check it.
I think I didn't get it.
Likely.
It sounds like either a value or an exception.
Yes.
Yes, this is another option.
Or you can just dismiss this exception if you check explicitly the correctness of the code.
This is all things you can do, provided you know how to handle such an exception. If it's in a validation stage, then yes. If it's somewhere deeper, sometimes we don't need to evaluate the precondition because we know it's met from other sources. For instance, if you don't want to over-index a vector, you usually use a loop in a vector and say it's from, suppose you're using indexes. You say that you are looping until you reach the maximum index. So the condition is already in the loop, so you don't have to revalidate it again when you're accessing the value of a vector, because it's been already evaluated by different means. So sometimes it's not really necessary to evaluate the precondition. It's only important that you are sure that it's met.
Okay, thanks very much. Andrzej Krzemiński.
Thank you.